These examples go with lesson 7.3, confidence intervals for a population proportion. Example 1. A simple random sample of 200 third graders in a large school district was chosen to participate in an after-school program to improve reading skills. After completing the program, the children were tested, and 142 of them showed improvement in their reading skills. Part A. Find a point estimate for the proportion of third graders in the school district whose reading scores would improve after completing the program. All right, this is going to be our p hat. And the only thing we have to work with is the 142 of them who received or who showed improvement and the 200 who were chosen to participate in the first place. So what we're really doing is finding a probability here. What's the probability that a third grader would show improvement after doing this program? So we're going to do 142 divided by 200, and then I'm going to see what that gives me in my calculator. And that actually gives me 0.71. So we didn't have to round this one. That came out very nicely there. All right, part B. Now we're going to construct a 95% confidence interval for the proportion of third graders in the school district whose reading scores would improve after completing the program. All right, so our confidence level is going to be 95%. And let's go ahead and get that critical value, which we're going to pull off of table A3 down there on the Z line. So here's table A3. Down at the bottom along the Z line, we've got 95%. This is going to be the number 1.960 that I'm going to use for my critical value. Okay, and let's get the other things that we need in order to do this confidence interval. All right, our standard error, we have a formula for that. That's going to be our p hat, our point estimate, times 1 minus our p hat, divided by the number of students in our sample, which is 200, and then we're going to take the square root of all of this, and I'm going to round this to 4 decimal places. And this is going to give me 0.0321. The margin of error is going to be our critical value, which we got off of table A3, times the standard error, which we just now found. All right, let's put that in the calculator. And this is going to give me 0.0629. And so our confidence interval, just going to put that down here. Remember, this is going to take our point estimate, which we said was 0.71, our p hat, and we are going to subtract off our margin of error. And then we're going to take our point estimate and we are going to add our margin of error. And then I'm going to round these to 2 decimal places because that's what my point estimate was rounded to. And this is going to give me my confidence interval of 0.65 to 0.77. Okay. Let's go on to the next slide because we got a couple more questions for this. Part C. Is it reasonable to conclude that more than 60% of the students would improve their reading scores after completing the program? Well, let's see. Our confidence interval went from 0.65 to 0.77. I'm just going to write that right here. And I would say that yes, it is reasonable to conclude that more than 60% of the students would improve their reading scores because 60% is going to fall over here to the left of our lowest end on our confidence interval, And remember, we made a 95% confidence interval right here. So we are 95% confident that the true mean falls between 0.65 and 0.77. All right, so yes, we are 95% confident that the true proportion, not the true mean, because we're dealing with proportions here, lies between 0.65 and 0.77. Now, Part D says that the district superintendent wants to construct a confidence interval for the proportion of all elementary school children in the district whose scores would improve should the sample of 200 third graders be used for this purpose. And the answer to this one is no, we should not use the sample of 200 third graders. And the reason is because this sample contains third graders only, and elementary contains students between kindergarten and 5th grade, 6th grade in some states. But anyhow, there's more than one grade in there other than the third grade. Also, we have to take into consideration that there's different age groups in these different categories or these different grades. And let's say a 6th grader is more likely to have a higher reading level than a 1st grader. And the 6th grader, while they have a higher reading level, may not show as much improvement as maybe a 1st grader would. So in short, no, this is not a good idea to contain just the 3rd graders to write a confidence interval for all elementary school children, because our sample has 3rd graders only. Example 2. In a preliminary study, a simple random sample of 100 computer chips was tested, and 17 of them were found to be defective. Now, another sample will be drawn in order to construct a 95% confidence interval for the proportion of chips that are defective. Use the results of the preliminary study to estimate the sample size needed so that the confidence interval will have a margin of error of 0.06. Okay, things we know. Our sample size is 100, and the number of computer chips that had our desired result, or undesired since they were defective, 17. All right, our confidence level is going to be 95%. And so we're going to need to go get a critical value from table A3 down there on the Z line. And then we want to have a margin of error of 0.06. All right, so let's go to table A3. Here's 95%, the critical value right above it, 1.960. All right, our formula to find the correct sample size, and we are looking for the sample size of the second run through, so we are actually not going to use this here, but we're going to use all of the rest of the data from this to try and figure out what sample size we want to achieve this desired margin of error. Okay, so we need to know what our p hat is, and that's going to be the number of defective chips divided by the number of chips that were in the sample, and this is going to give us 0.17. So the formula tells us we're going to take our p hat, we're going to multiply it by 1 minus the p hat, and we're going to multiply that by our critical value divided by the margin of error that we want, and this is going to have to be squared. Okay, and we should be able to put this directly in the calculator, so let's see what we get. And this is going to give me 150.6, but remember, we want to round this up to 151. Remember, rounding up is okay. It's going to reduce the margin of error. That's okay. We don't mind going smaller. We just don't want to go larger than 0.06. So it looks like our correct sample size is going to be 151. Example 3. A pollster is going to sample a number of voters in a large city and construct a 98% confidence interval for the proportion to support the incumbent candidate for mayor. Find a sample size so that the margin of error will be no larger than 0.05. Okay, this time we know our confidence level is 98%, and we're going to need to pull up table A3 in order to find our critical value. All right, down here, 98%, and right above it, the critical value, 2.326. And we know we want the margin of error to be 0.05 or less. Now, this time they didn't give us a sample size and they didn't tell us how many items actually fell into the desired category, so we can't get our p-hat. And this is a time when we want to use that p-hat as 0.50. And there was another formula that you could put this into, but I'm going to go ahead and use the one that we did before, and that's going to be the sample size is equal to our p-hat times 1 minus our p-hat times the critical value divided by our desired margin of error, and we want to square that. Okay, so let's put this in the calculator and see what our sample size should be. And this is going to give me 541.0, but if we look at the rest of the decimals, we've got 276. So we always want to round this up, even though the decimal is so small. And remember, that's because if we round up, it's going to make our margin of error go down, whereas if we round down, it's going to make our margin of error go up. So we want 42. It looks like 542 is going to be the sample size we need that will give us a margin of error, in this case, less than 0.05. Example 4, a pollster is planning to draw a simple random sample of 500 people in Colorado, population about 5.0 million. He will then conduct a similar poll in Texas, population 24.7 million. He wants to have approximately the same standard error in both polls. True or false? A. The pollster needs a sample in Texas that is about 5 times as large as the one in Colorado. And the answer to part A might surprise you, but in spite of the fact that the Texas population is about 5 times as large as the Colorado population, this is actually false. Okay, and this is all because the margin of error has nothing to do with the population size. Okay, and the margin of error, of course, is going to be the one that has an effect on the standard error there. All right, part B, the pollster needs a sample in Texas that is about the same size as the one in Colorado. So this one we're going to say is true. And the same reason here, we know that our margin of error doesn't really depend on the population size, so we might as well get sample sizes that are about the same as one another. Example 5, a marketing firm in New York City, population 8.4 million, plans to draw a simple random sample of 1,000 people to estimate the proportion who have heard about a new product. The firm then plans to take a simple random sample of 500 in Denver, population 610,000, for the same purpose. True or false? The margin of error for a 95% confidence interval will be larger in New York. Okay, let's see. Okay, so what I have up here are the formulas for the margin of error that we've used. We said the margin of error is the standard error times the critical value. Now, when we're working with proportions, that means we're going to use the formula p hat times 1 minus p hat divided by n, and then we're going to square root it, and then we're going to multiply that by the critical value. Okay, so it doesn't matter whether we're in Denver or whether we're in New York City, the critical value is going to be the same. So we need to take a look at this right here, because what's going to change is in Denver, we're dealing with 500 people in a sample size, and in New York, we're dealing with a sample size of 1,000. So those are my n's. Okay, let's take a look at this fraction right here. As we increase the size of n, or the denominator in a fraction, it causes the value of my fraction to decrease or to get smaller. So the fact that 1,000 is going to be a larger sample size than 500 means that this is going to cause New York City's margin of error to actually be smaller than Denver's, because the 1,000 is going to give me a smaller fraction here to take the square root of. So this one is going to be false. All right, and then we look at B, the margin of error for 95% confidence interval will be larger in Denver. Well, we kind of already answered that, because 500, which is going to decrease down here in the denominator, that's going to be the opposite. That's going to actually increase the value of my fraction here, and then when I take the square root of it. So this one is going to be true. The confidence interval is going to be larger for Denver. And then the last one, the confidence interval is going to be about the same. Well, it can't be about the same if Denver is going to be bigger, so this is going to have to be false also. Example 6. In a simple random sample of 15 seniors from a certain college, 8 of them had found jobs. Use the small sample method to construct a 95% confidence interval for the proportion of seniors at that college who have found jobs. All right, this time, instead of finding p hat, we are going to be looking for the p squiggle. And the p squiggle tells me I want to take, well, let's look at the things that we know. Our sample size here is 15. The number of items in the sample that have our desired result is 8, because 8 people found jobs. And of course, our confidence level, we want to use 95%. Okay. All right, so our p squiggle, we're going to take our number of items that have our desired result, and we're going to add 2. And then we're going to take our sample size, and we're going to add 4. So this is going to be 10 over 19, and let's see what the calculator gives us. And this gives me 0.5263. Okay, our critical value is going to come from table A3 on the Z line at 95%. So 95%, the critical value, 1.960. The standard error is going to be our p squiggle times 1 minus our p squiggle divided by sample size plus 4, and then we are going to square root all of this. So let's see what the calculator gives us. And this gives me 0.1145. Our margin of error is going to be the critical value from table A3 times the standard error that we just now found, and that's going to give us 0.2244. All right, so our confidence interval, we're going to take our p squiggle, and we are going to subtract off our margin of error, and then we're going to take our p squiggle And we are going to add the margin of error. Let's see what we get. And this is going to give me the interval going from 0.3019 to 0.7507. So there is our confidence interval based on our small sample size.